Here we're going to construct a contingency table for the promotional status of police officers during the past 2 years. This is a problem out of the book in Chapter 2. We are told that a police force consists of 1,200 officers, 960 men, and 240 women. Over the past 2 years, 324 officers have been promoted. After reviewing the promotional record, a committee of female officers filed a discrimination case on the basis that only 36 female officers had received promotion during the past 2 years. Now, the police administration argued that the relatively low number of promotions for female officers is due not to discrimination, but to the fact that few female officers are on the force. We are going to use conditional probability to evaluate the discrimination charge. We're going to take the data and see if the promotion and gender are dependent events as put forth by the females, or if they are independent events as put forth by the police administration. So if you haven't already done so, take a few moments and set up a workbook that looks like this. Now my center section here is just for review purposes so that you can see the terms and follow along with what we're doing. You don't necessarily need to include that in your workbook. Now we'll go ahead and enter in the data that we are given. We are told that on the force we have 960 men and 240 women. So we will take and use our Excel functions and find the total number of folks on the force. We know that this should sum up to 1,200, and it does. Now, of these 1,200, a total of 324 were promoted, and 36 were female. So the number of men promoted is going to equal the difference. So equals our 324 minus this cell, 36, 288. Now we can calculate the number of men not promoted. That is going to equal the number of men, 960, minus the number of men promoted, 672. We will do the same thing for females. Remember, you can go to the box here in the lower right-hand corner, drag it down to copy your formulas. We have 204 females that were not promoted. So now the total number of females, again, is going to equal the sum, the total number of officers not promoted. It's going to equal the sum of men and women not promoted. Okay. So this is going to be our data table. This is the information that we will analyze. We want to calculate the union between promoted men and not promoted men. Now, looking at this table here, these probabilities in the body of the table are what are called joint probabilities. The ones along the edges, these and these, are called our marginal probabilities. Okay. Now, to calculate these, we simply use division. So, men and promoted equals 288 divided by 1,200, the total number on the force. And women is going to equal 36 divided by 1,200. Okay, so what this is saying is that of the 1,200 people on the force, 24% that were promoted were men, and women promoted consisted of 3% of the force. So the total officers promoted is the sum of the men and the women promoted, or we can see that 27% of our force was promoted. So now we'll do the same thing for not promoted. 672 divided by 1,200. And 204 divided by 1,200. Again, we want the sum of those. And we can also see that on our force, 80% are men, 20% are women. And if we add this up, we've got 100% of our force. We can also see that the total promoted plus not promoted equals 100% as well. 27% were promoted, 73% were not promoted. Okay? So this is just a double check that our calculations are correct. We haven't misentered a number here. So now we can answer the question if gender and promotion are dependent or independent events. So let's take a look again at the rule. Rule for independent events states that the probability of being promoted if you're a man is the same as the probability of being promoted. So then the probability of being promoted if you're a woman is the same as the probability of being promoted. Essentially, gender has nothing to do with it. That would say that these are independent events. So in our model, the probability of being promoted, we've already calculated, equals this 27%. So now we need to calculate the probability of being a man promoted and the probability of being a woman promoted. And here's our equation for men. And I'm going to enter these numbers in so that you can see them, and then we'll do the calculation to the right. So we had 24% right here. It's the probability of being a promoted man. And how many were men? Well, 80%, so 0.8 here, right? We are going to divide those. So do the calculation over here. So 0.24 divided by 0.8, 0.30, 30%. Okay, so now we want to do the same thing for women. We have 0.03 and 0.2, 20% on our force are women. And I don't want to do it that way. Okay, so I'll do the calculation right here. 0.03 divided by 0.2. Okay, so looking at these three numbers, 0.27, 0.3, and 0.15, we can see that these three values are different. So the probability of being promoted, the probability of being a man and promoted, and the probability of being a woman and promoted are all different. Therefore, we can see that gender and promotion are dependent events because these values are not equal. Okay, so thus the argument brought forth by the female officers is justified. We can't in fact say that discrimination exists, but looking at the probabilities and the numbers, we can say that their argument is justified.